Good day, everyone. Today I will be discussing all about application of derivatives in real life. Nowadays, application of derivatives to real-world scenario are being made almost everywhere. For example, in running a business. Officially, it required us to maximize the profit and measure the rate of increase in profit relative to the quantity produced to effectively make money. We can also calculate temperature variation to find out which is the hottest or coldest, and estimate what is the next occurrence of the earthquake will be, and find the velocity and acceleration of an object. So all these examples requires derivatives. For this video, we will use derivatives to find the velocity and acceleration of an object, as it is the most applicable scenario because with only a position function given, we are able to find the velocity and acceleration of an object since this all measures the rate of change each other. So what exactly is a derivative? A derivative is a function that shows us the rate of change of a variable relative to another. It may also be defined as a slope or gradient of contingent line to a curve at a given point. Derivatives are presented as dy over dx, and the process of finding derivative of a function is called differentiation. So here is the basic way to differentiate a function. In this method, we're using what we call the power rule, where the power of x gets subtracted by 1 while the entire function is multiplied by the value of original power. So let's say, for example, you work from a sports car company and recently you and your team finished full-time for brand new sports car. Now, you and your group of researchers are responsible for testing the product's performance and capabilities to see whether or not the product meets the company's expectation and if it can be produced to the market. So there are a few things that are required to report about. Number 1, or the first, is the speed at which the car moves, or in other words, its velocity at a given time. Next is the car's acceleration at a given time and the duration it takes for the car to reach a specific speed. So basically, we will be using derivatives to find the velocity and acceleration. So how exactly do we use derivatives to calculate velocity and acceleration? So, to find both acceleration and velocity, find the function that shows the object's displacement at a given time, or what we usually call the position function. So to find the velocity at a given time, all we have to do is to find the derivative of a function. Then, substitute the value of the time, and the same thing goes to finding acceleration. So instead of finding the derivative of a function, we need to find the derivative of the velocity function. So for example, the displacement meter of a car moving in a straight line is given by this equation, where t measured in seconds. S equals t raised to 3 plus 5t plus 10. So, and we are to find out first the velocity of the car at 5 seconds, next the acceleration at 3 seconds, and the duration it takes for the car to reach 500 meters per second. First thing we need to do is to find the velocity function, which is given by derivative of displacement function. So to do this, we need to use the power rule as we explained before to get the velocity function. So to get d over dx, times the quantity x raised to n power equals nx raised to n minus 1. So, to get the equation 30t squared plus 5. To find the velocity of a car at 5 seconds, we just have to insert the value and finally get the velocity of car, which is 755 meters per second. Secondly, we need to find the acceleration function. So to find the acceleration function, we have to find the derivative of velocity function. To do this, we use the power rule again, just like the first equation, and this should give us the equation, which is 60t. We insert the value and get 180 meters per second squared. For the last question, it still talks about the velocity, but instead of finding the value of the velocity, it requires us to find the time. So, we know that velocity is given by this equation 30t squared plus 5. So, find time taken to reach 500 meters per second, which makes this equation equal to 500 meters per second. So, move things around and we should get 4.06 seconds. So, as you can see, finding out the velocity and acceleration using derivatives was made easy. So these are the references of the presentation we gathered, and that would be all. Thank you for listening and have a great day. Happy learning!